So today we are computing the automorphic the Galois group of R real number over Q. Okay, so people like to write as R over Q or Galois group R over Q. Okay, so let me just quickly remind you guys that so now we need to review R and Q are the what are the field, right? So basically these are F basically from R to R, which is isomorphism as a homomorphism of field, but the fixed Q. So f of x equals to x for all x belongs to Q. And all of these forms a group. So theorem, what I want to prove is that the Galois group of R over Q is trivial. So basically, the only map from R to R is the identity map. So there's only one element that's called F, right? And this F is just x to x. Oh, sorry, it's just f of x just equals to x for all x belongs to R. Okay, so this is a trivial group. Okay. Okay, so the proof. Okay, the proof. So let's say the step one. So the step one is that okay, so let's take. So there it needs some analysis. So if suppose we take F belongs to like this group, then we want to ask what is, right? We want to ask what is f of x, right? Suppose we also take x belongs to real. Okay, so step one I want to show is that I want to show this. I want to show this: if a less than b, then f of a must less than or equal to f of b. And the proof is that suppose f of b minus f of a, right? So this is f b minus a because this is a field homomorphism, and this is also a square root of b minus a square. So it's f square b minus a square. So notice that f is a field homomorphism, so it has a property that if you get minus the minus 2 of f, then it can be changed into the variable inside the bracket, and then you take a square root, and then so this is larger than 0 because this is some real number square. Okay, so proof done. Okay, step 2 is also easy, right? So we can take real like Rn belongs to the rationals for each n, and the Rn is increasing. So given any x, right? Given any x on the real numbers, I can take some increasing real rational sequence approach to x. So R approach to x, but increasing. So and all Rn is rationals. So that means what? That means what? So basically, we know that f of Rn is less than f of x, and then we take a limit from both sides. So take n goes to infinity. So and Rn is rational, so this is Rn. So what we have is n goes to infinity, limit Rn less than f of x. So this implies that x less than f of x. Okay. On the other hand, we can do the same thing. We can take another sequence, let's say Sn, which decreasing to x, and do the same computation. So for example, right, s less than s of n, so f of x is just less than f of Sn, right? But Sn is also rationals, so Sn, and then take n equals to infinity. This gives you f of x less than x, less or equal to x. So from these two, we know that f of x is x. So f is only identity. Okay, so proof are done. So basically, this proof use the property of analysis and First, you use the property of analysis. Also, you use the rationals, the property of rationals. So that's why the Galois group of real over the rationals is trivial. It's a trivial group. And thanks. I will see you guys in the next videos.